Yeah, this is the situation when warm water is just loading without, let's say, checking the outcoming temperature. My first modification was that I disconnected the NTC, which is inside the warm water indirect exchanger. This is warm water indirect exchanger, and you see that I put here is tiny cable, and I used one NTC sensor the same type. It cost me €1 on eBay. Yeah, it's really cheap, and I put it here on reversing the primer. This is the primer circuit. Here is coming in the primer circuit, and here is coming out. And you consider when there is no more exchange that water, because the primer circuit is very restricted. The Bosch is saving on material, please. Yeah, this is the problem, that this heat exchanger cannot exchange all the energy. Now this is very hot, it has 55 degrees Celsius, but upcoming water is very cold because I set up only 40 degrees Celsius. You see, here is 55 degrees Celsius and here is only 40 degrees Celsius. And inside the water is, okay, now it's almost 40 degrees, but usually inside is maybe 35, 36 degrees, yeah, because everything is collapsed due to limited surface for exchanging. Yeah, now it's cooling down. You see that it's very slowly cooling down because this kettle can moderate only to the minimum power 7 kilowatts, and 7 kilowatts is still too much to exchange to make smooth exchanging of the water. So you have to let the kettle to be cycling. And my first improvisation was that I picked up the original. I disconnected. Yeah, this is just like it's, yeah, I can show you. Here we are. You see, here is disconnected the original. I should also blind a little bit. And somewhere here is, yeah, here you see, here is connected. I don't know where. Yeah, somewhere here, maybe this one and this one. I don't know which one, but it looks to be like this one and this one. Here is connected this NTC sensor, yeah, directly this NTC sensor. And now I'm sensing basically the returning cycle. When returning cycle is called down, that there is exchange, there is overtaken the energy from the primer circuit, it will repeat it, the action. But sometimes in this situation that water is quite warm and there is no repetition. But this is quite good. But if I want to prepare really fast, because this is preparing me water for a whole day, very lazy but very efficient, or quite efficient, much more efficient, yeah. But if I want to prepare the water faster, I prepared such a clamp. Yeah, I hope that it will be, yeah, crazy. I hope that it will be exchanging enough. Yeah, this is what? Oh, this is going to the radiators. Yeah, I prepared this clamp, but I think that this clamp is not very familiar with this rounding. Yeah, it's not very familiar. Okay, I need maybe modify a little bit this clamp, because it must be, yeah, it's more familiar with this curving but not with this curving. Yeah, but basically, to know what's going on, I prepared this clamp. It's going together like this, and on the side I'll be mounting two NTC sensors, like one here and one here, yeah. And I can achieve some incredible thing, yeah, that I can connect these NTCs. I hope that everything will be possible to put in together. I can sense with these two NTCs the temperature, and I can connect all 3 or 2 NTCs parallelly, and this can be doubled reaction, something like doubled reaction. So if, because problem is that this outgoing temperature, the kettle and electronic doesn't care about outgoing temperature, and kettle just cares about other temperatures, like inside the warm water, on the heating systems, but never cares about outgoing temperature. No, in heating system you can limit outgoing, but not for water. For water it doesn't care. So I prepared one thing, one improvisation, that I'll be getting this all NTCs parallelly, and it means that I limited the highest temperature, because the gradient of the decreasing, because it's negative, it's decreasing the ohmic resistance. The gradient of the increasing of the ohmic resistance related to temperature will be doubled or tripled, basically. No, tripled, because it's one third. It will be one third. Yeah, it will be one third. Yeah, maybe it's tripled. Yeah. So it will be quite interesting for tomorrow. Thank you very much for the watching the video, and I'm looking forward for tomorrow, maybe couple of next days, because I'm still in hurry.